Welcome to your AP Statistics video on Chapter 5, Understanding and Comparing Distributions. I'm here with my doggies, Daisy and Scout, and so if you hear any barks or sounds that seem kind of strange, chances are they're coming from the doggies. Okay, so understanding and comparing distributions is incredibly important. And the ability to communicate well what's going on in the two distributions is a critical skill in AP statistics. So let's look. We can answer much more interesting questions about variables when we can compare two groups. We're going to start off with one group and then we'll branch out to two. So below is a histogram of the average wind speed for every day in 1989, which is the year I graduated from high school. Fun fact. Okay, yes, I'm old. So we've got a maximum of 8.67, a minimum of 0.20. So that gives us an idea of the range. The median is 1.90, so half were above 1.90, half were below. The first quartile is 1.15, so that makes a 25%, 75% split. And the third quartile is 2.93. So that gives us a 75%, 25% split. So just to kind of give you an idea, the distribution is certainly unimodal and skewed to the right. The high value might be an outlier. We'd need a test for that. Do the whole fence rule and everything to determine that. Median daily wind speed is about 1.9 miles per hour. And then using the Q3 and Q1 we talked about earlier, we subtract to get an interquartile range of 1.78 miles per hour. The question always is, can we say more? So the 5-number summary gives us some specific values that we've already gone over. Another way to display this data, any quantitative data, is with a box plot. And it is a graphical display of the 5-number summary. So it's really nice because not only can you see the approximate values of each of the 5 numbers, but it gives you an idea of where there's more or less spread within a group and between groups. They're also really good at pointing out outliers. Okay, you can dot in the fences, and then anything that goes past that is an outlier. Really nice. All right, so I mentioned fences, so let's talk about the box part, the whiskers, and the fences. Box plots are also called box and whisker plots, and we'll talk about that in just one second. Now, this particular box plot that we're going to draw is arranged vertically. Your calculator is typically going to arrange them horizontally, and that's a little more traditional orientation of a box plot, but it doesn't hurt us to look at a vertical orientation. And also that way, hopefully that will help you remember that that's fine, even though you're going to see many examples of horizontal box plots. All right, so there's going to be a single axis. In this case, it's a vertical axis, and you need to make sure it spans the entirety of from the minimum, below the minimum to above the maximum value. And you want to do little hash marks there. And then over here, you want to start with the box, okay? The box part of the box plot goes from Q1 to Q3 with the median shown in the middle. So this is kind of nice because you get a visual representation of the IQR since this goes from Q3 to Q1. All right. Now, you want to go ahead and put in the fences, which are going to be 1.5 IQRs above the upper quartile, the third quartile, and 1.5 IQRs below the lower quartile. And remember, these fences tell us if any values are outliers. If the extensions we're going to make go beyond the fences, then we know we have outliers. Now, technically, these are not part of the box plot itself. It's just going to help us determine outliers. So you want to do this really lightly so that you can erase them at the end. All right. So I've mentioned whiskers. Now it's time to talk about the whiskers. The whiskers are these extensions that go from the quartiles to either the minimum value here from Q1, the maximum value from Q3. So what we expect is for all the data to fall within the fences. Okay, and that's what happens here. Should either one of these whiskers have extended beyond the fences, then we would have outliers in that direction. From there, we will, should we have any values that extend beyond the fences, we are going to mark them with a special symbol. Often we will use one symbol for just typical outliers that fall outside the fence, but anything that falls farther than 3 IQRs, we'll use an even more special symbol for those. If you remember to do that, that's great, but you certainly don't have to. Sometimes when we make note of the outliers, this is called a modified box plot. You can feel free to go ahead and use a modified box plot anytime you're asked for a box plot, but you don't have to unless it specifies modified. Okay, but that's always an option. So how do we know where our whisker ends if we have outliers? Because certainly, like this one's not going to go all the way up to the maximum. Then, in this case, the whisker goes to the highest non-outlier value. If it were the situation where we had low outlier values, the whisker would go to the lowest non-outlier value. Okay, so we're going to compare the histogram and box plots for daily wind speeds. We're going to look at spring, summer versus fall, winter. So here we've got the spring and summer, the fall and winter. And the question is, what does this graphical display tell you? So we look at it, and from the histogram, one thing we can see is that in the spring and winter, the mode occurs at a lower value, somewhere between 0 and 1, than in the fall and winter. Okay. It has a mode here a little bit above 2. They are both skewed to the right. And the fall and winter seems to potentially have an outlier. We can do a more formal test for that when we look at the box plot. So let's see what the box plot adds to this. This box plot actually is going to give us a lot more detail because they're going to compare month to month. And this actually gives you kind of an interesting amount of information here. So we go from January to December, and you can certainly see that as things heat up, there is a dip in the wind speed, and then as it cools down, the wind speed increases. November had an extremely windy day. That's had to be an interesting day there. We see that there are outliers in November, December as fall is turning into winter, and there are outliers here where spring is turning into summer. There's one down here in July. So this gives us a lot of interesting information. Certainly, uh, the variability also decreases as we get warmer and then increases again as we get colder. And you can see how the medians compare. The general trend is that as we go again from January to July, the median decreases. And then July, August, September, the median values tend to go up with a little bit of a dip there in December. So lots of interesting information given in the box plots. So what about outliers? Like I said, if there are any clear outliers and you were reporting the mean and standard deviation, report them with the outliers present and with the outliers removed. The differences may be quite revealing. The median and the IQR, if you'll remember, are more resistant to the outliers, so they're not as likely to be affected by them. All right. Sometimes we want to know what trends are over time, and we construct a time plot. It's a little bit kind of what was happening here going from January to December, But let's look at it where we have the individual day values. Okay, you can see though that there's this general trend that we noticed before. So here we have the starting off in January and then dipping down as we move to July and then increasing back up in December. Here's our potential outlier from November. So we are going to revisit the shoe example, but we're going to look at not just the distribution of the women, we're going to add distribution of shoes owned by men. So here we have a box plot of our distribution of shoes owned by women. So you can see that the median here is somewhere around 20, 21. First quartile is around 9. Uh, third quartile is around 25. And we go from, let's see, 4 all the way up to 35. Okay, gives us a good idea here. Remember, there's the same number of observations in this little whisker as there is in this pretty big space between Q3 and the median. And there's not a whole lot of variability here between the median and Q3. There's a bunch of values packed in really tightly there. And then there's quite a bit of spread in this last 25%. Okay, so yes, the distance from minimum to Q1, Q1 to median, median to Q3, and Q3 to maximum varies, but the number of observations that fall into each quartile are the same. So it shows you where there's more spread. So that's something you can pick up for information within a distribution. Let's look at the distribution of men's shoes, and then we will compare the two. So here we've got the distribution of the men's shoes. Again, just like I talked about earlier, we could go through and estimate the numbers in the 5 number summary. We can talk about where there is less variability and where there's more variability within the distribution. But the more important, the thing that is critical that you are able to do is to be able to compare two distributions. The nice thing about your graphing calculator is it's super easy to go between box plots and dot plots. Histograms also. In fact, I think a histogram might be really helpful for determining shape in this case. Stem plots are great to use too, but your calculator can't do those for you. All right, so here we have the distribution of the women in both box plot and dot plot form. Here is the distribution of the men in box plot and dot plot form. Now, one thing that you need to recognize is that the scales here are different. Okay, if I were drawing these on one plot, so, or if I had to draw these, I would do these on one plot so that you could really see, oh yeah, these are not extending out to the same value. The maximum here for the men is right here around 22, clearly below the maximum for women. Although when you first glance at this, because if you don't stop and look at the scales, you might have a misunderstanding. All right, so when we compare, we want to back up we want to give our observations with direction. Something's greater than something else, something's less than something else. And we want to back it up with numerical proof whenever we can, or numerical evidence. Whereas the women's distribution appears to be skewed left, the men's distribution appears to be slightly skewed to the right. According to the box plot, neither distribution has an outlier. The median of the women's distribution, 20, is much higher than the median of the men's distribution, 9. Notice the higher. You would think being able to just say the median for the women is 20 and the median, whereas the median for the men is 9, would imply that the women's is higher, but it is your job to communicate that you realize that fact, that based on the women's median being 20 and the men's median being 9, that the women's is in fact higher. Okay, the range for the women, 31, was greater than the range for the men, 19. The IQR for the women, 15.5, was also larger than the IQR for men, 7.5. So in summary, we have a different direction of the skew, women's to the left, men's to the right. And the women's center is higher and it's got greater variability than the men's. All right. So for the next problem, I invite you to pause the video, go grab your textbook so you can look at the problem on page 97. We're starting with number 16, and we're going to compare the distribution of prices over the 3 years. All right. The median gas price increased over the 3 years. The spread increased as well. The prices in 2002 were skewed to the left with several low outliers. In 2003 and 2004, the distribution became increasingly skewed to the right. There was one high outlier in 2004. I haven't really emphasize this so far in the video, but please take note that when we're doing the distribution, just like when we're doing a description, we make sure that we hit shape, outliers, center, and spread. Okay, make sure you mind your socks. In what years were the prices least stable? Explain. Okay, so the year with the greatest variability has the least stability. Since 2004 has both the largest range and IQR, it has the greatest variability and the least stability. All right, now look at problem 18 on page 98. Both the median fuel efficiency and the spread decreased from 4 to 6 to 8 cylinders. There's not enough information on 5-cylinder cars, which seem unusual, to include them in the discussion. The lower 75% of miles per gallon for the 8-cylinder cars correspond roughly to the bottom 25% of 6-cylinder cars. All of the 8-cylinder cars get less mileage than any of the 4-cylinder cars. The overall trend seems to be the greater the number of cylinders in a car, the lower the fuel efficiency. All right, moving on to problem 21. Our first step is going to be to identify the approximate value of the medians of the histograms and compare with the box plot. Class 1 and Class 2 both have medians a little higher than 60. Class 3 has a median in the upper 80s. Box plot A and B have lower medians, and box plot C has one in the upper 80s. Thus, Class 3 goes with box plot C. Step 2, consider the spread of the distribution about the medians of the classes 1 and 2 to match to the appropriate box plot. So in this case, to differentiate between these two, we got to look at the spread. Class 1 has a bell-shaped curve, meaning that there is a higher frequencies for grades closer to the middle and lower frequencies as grades move away from the middle. Thus, there is less spread in the middle 50%, it's more highly concentrated, and more spread in the outer 50%. Okay, it's going to be more, the values are more spread out in the whiskers. So that is reflected in box plot A. So Class 1 goes with A, and by process of elimination, Class 2 goes with B. All right, guys, that is it. Please try the problems to try on your own. Thank you so much for your attention to the video. I look forward to discussing this further with you in class. Have a great day.